So now we're in the section for multiplying and dividing fractions. Let's take a look at it. Mr. Bill brings a candy bar to the upper L meeting. He gives 1/3 to Miss Carrie and the other half to the 6 upper L teachers who eat sugar. How much of a candy bar does each one get? So our statement would be each gets of the candy bar, of the bar. Each get of the bar. And so we have the candy bar. And here it is. So what happens to it? Well, Miss Carrie gets 1/3. This is Miss Carrie. And then the other half goes to 6. So well, it's not the other half, the other part, right? It's the other part. What's left goes to the 6 people. So we have to divide this part up into 6. So that would be 3 and 3. So let's divide it up into 3 and 3. So there we go. So now here's each of the 6 teachers gets one of these parts. But how much is that? Well, you imagine, what if I'd done this to each of the parts? What if I'd also done it here? Okay. So, well, these are 9ths. 3 times 3 is 9. So this is a 9th. So each of the pieces is left as a 9th. So really we have 2/3. And of the 2/3, I get 1/6 if I'm a teacher. So I got 2/18 or 1/9. Okay. Now the other way to do it, as you see here when we get to 2/18, is we could have said if it was harder to see, so we've done it this way before too, is, well, we'll divide this into 6 parts. And this one into 6 parts. And how much does each teacher get? Gets one of these and one of these, 1 out of 6 of each parts. And that would be how you see the 2/18. So it depends on how you want to work it. In either way, you get 1/9. Okay, so we get 1/9. So in this one, this is our first example of fraction division. So we have M&Ms, so we have a whole bunch of them. We're going to scoop it out into 1/4 cups. So our portion is 1/4 of a cup. So another way to think of this problem is, if you had 4 7/8 pizzas, how many 1/4 portions could you get from it? So first we're going to draw it out. So we have our M&Ms. And altogether, there's 4 7/8. And what are we doing is, we're cutting them up into 1/4 cups. So we could think of it this way, that we have 1 cup, 2 cups, 3 cups, 4 cups, and then this last one is 7/8 of a cup. Okay, so what happens? Well, how many do you get from, how many 1/4 of a cup do you get here? Okay, so I got, from here, I get 4 scoops. So from each one, so let's do the next one. From the next one, I get 1, 2, 3, 4 scoops. From the next one, I get 1, 2, 3, 4 scoops. From the next one, I get 1, 2, 3. So in other words, from each cup, I get 4 portions. So I do that 4 times. So I get 4 times 4, so I get 16 scoops. But then I have this last one. Let's zoom in on that one. So let's zoom in on that one. So this is 7/8 of a cup. Okay. Well, if we think about a fourth is equal to 2/8. Okay. So let's take a portion here. So we get 2/8. So here's 2/8, one portion. 2/8, another portion. 2/8, another portion. How about this last one? So this last one is an eighth. Well, what is 1/8 to 2/8? It's half, right? So this is half of it. So we've got up here, from the first 4 cups, we get 4 portions from each. So this is 16. So there we've gotten our 16. And then we got 17, 18, 19 portions, and then a half. So we have 19 and a half. So we have 19 and a half portions. So in looking at this area problem, this box, so the box has these 2 dimensions, so we're assuming it's a rectangular box. So let's make a little picture of that. So we're saying it's a 3 5/8 feet by 3 7/8 feet. Okay. So we want to multiply those 2 things, but to multiply them, we switch to being an improper fraction. So let's do that. So 3 5/8. So you say 3 times 8, there's 24/8 from the wholes, plus 5, there's 29/8. So okay, there's 29/8. And then the 3 7/8. So okay, 3 times 8, 24 plus 7 is 31/8. Okay, so we multiply our tops and bottoms. So it's easier if you put the 29 on the bottom, if you think about it. Alright, so let's put the 29 on the bottom. So then we get a very easy multiplication. We get 1 times 29 is 29. Now we'll multiply by the 30, so we get 3 times 9, 27, 2 to carry. So 870, 9, 899. So just 1 less than 30 times 30. Okay. So we have 899. We have to multiply the eighths times the eighths, so we're going to cut each eighth into 8 parts, so we'll get 64ths. Okay, so then we do the division on this. So let's do our division. So we can get a mixed number divided by 64. So you can share out 89 tens once to 64, and we get 25 left. 259. Oh, this looks like it'll work out pretty well. Times 4, 4 times 60 is 240, 4 times 4 is 16, 240 plus 216 is 256. So we have 3 left, so we have 3 out of 64. So our answer should be 14 and 3/64. Now does this answer make sense? Well, this is about, if you think of the lower bound, if we round down, it should be more than 3 times 3. If we go up, we can go up to 4. And this one would go up to 4. So we should be between 3 times 3 and 3 times 4. So between 9 and 16. And since they are closer to 4 than to 3, we're near our upper bound of 16. So it looks good. So we have in this problem fraction multiplication. 7/8 of the students prefer pizza to spaghetti. Of those who prefer pizza to spaghetti, so of the 7/8, 4 out of 5 prefer lemonade to juice. What fraction prefer pizza and lemonade together? Okay, so it would be oomph of the students. Oomph of the students prefer pizza and lemonade. They prefer that combination. And so when we look at it, so we start out with, so what is it we're looking at? Well, we're really looking at the students. So we look at the students, and we say that our first division of students is 7/8. So we divide in half, divide each half in half. So now we have fourths. Okay. Divide each fourth in half. So now there's our eighth. Okay. How many do we have? We have 7/8 like pizza. So there's our 7/8. Now we're going to take each of these guys, each of these eighths, and cut them up into 5 parts. Not so easy to do, right? 1, 2, 3, 4, 5. And of those, so let's expand it out. So here's one of our eighths, and in that eighth, we're going to take 4 out of 5. So the question is, if I cut an eighth divided into 5 parts, what will it be? Okay, so each of these pieces here is a 40th. And so I'm going to take 4 out of 5, but that's going to happen for each one. So here I'm going to take 4 40ths, 4 40ths. I'm going to do that 7 times. So this, in the next one I do the same thing, right? I take out of the 5, I'm going to take 4. Okay, so I'm going to do that 7 times. So I'm going to end up with 28 40ths. But you say to yourself, well, I can reduce that. So you see, well, there's a 2 in each of them, but there's a 4 in each of them, right? So I can get 7/10. So there's my answer, 7/10. Sterling campus has an area of 7/8 of kilometers. One dimension is 3/4. So this problem is quite easy if you look at it with whole numbers. The area of Sterling is, let's say, 15. Area equals 15, and you know that one dimension is 3. What's the other dimension? So then you would just say, well, oh well, 15 divided by 3 equals 5. So it would be easy to do. But what if you have fractions instead? Well, you do the exact same thing, except now you have fractions. So if our area equals 7/8, and one of the dimensions is 3/4, what's the other dimension? So we're going to divide. So we say 7/8 divided by 3/4. Okay, and we've learned that division by a fraction is like multiplication by the reciprocal of this. So that's the same as 7/8 times 4/3. Okay. And so, okay, we can do that. So 7 times 4 is 28. 8 times 3 is 24. So that equals 1 and 4 24ths, which equals 1 and 1/6. Okay? So it's always good to check our answer. So we think that this is the answer, 1 and 1/6. Well, let's multiply. So this times 1 and 1/6 should equal 7/8. So let's try it. So 3/4 times 1 and 1/6. Well, let's make them both into improper. Well, make 1 and 1/6 into improper. So that'll be 7/6. That equals 21/24. 21/24 is equivalent to 7/8. So it looks like we're okay.